Now let's look at what regulates the digestive process within the stomach itself, okay? There's going to be 3 different phases, which we're going to look at there. But what is regulating the muscle contraction of the stomach, or what's doing the motility of the stomach? Well, those are associated with something that's called the pacemaker cells. Let me go back to this. So there's pacemaker cells. And these self-regulate, or they spontaneously depolarize, and it's something less than 4 times a minute, okay? So 3-4 times a minute, something like that. And what that does is it sends an electrical discharge, okay, which then causes the other smooth muscles of the stomach to contract. And just like in the cardiac muscles, you have gap junctions here that allows for that charge, okay, that action potential to propagate, okay? Now, the nervous system as well as your endocrine system regulates those contractions, not by the rate of contractions, because that is a fixed number. That is less than 4. That doesn't change. But we can regulate the force of the contraction, okay? So let's look at the 3 phases. The 3 phases for the stomach is going to be, the first one is going to be cephalic. Second one is going to be gastric. And the third one is going to be intestinal. So we're going to look at all 3 of these phases, okay? So now let's look at, starting off with number 1, let's look at the cephalic phase. So let's open this picture up. Hopefully that's good enough size for what we're looking at, okay? So here's the cephalic phase. And what the cephalic phase, well, okay, let's back up a little bit. The cephalic phase, and these are in order, okay, so the process. So the first step is going to be cephalic. Second one is gastric. The cephalic phase and the gastric phase occur before and during a meal. Okay, so that's happening there. The intestinal phase occurs after the meal. Okay, so now we have the basics. So when we look at the cephalic phase, here's what I want you to do. I want you to close your eyes, and I want you to think about walking into your house. Hopefully your eyes are open when you're walking into the house, otherwise you'd trip. So when you're walking into the house, imagine the smell of fresh baked bread or cookies right out of the oven. Okay? Or if you're going home to your parents and they're making your favorite meal. Okay? What's happening in this process? That's all up in your head. Okay? That's the cerebral cephalic process. It can be stimulated by thought. Okay, you just thought about the smell of fresh baked bread or homemade cookies. All right. It can be triggered. Now let's say you are walking into the house after a long day's work and your parents or your spouse has made your favorite meal and you can smell the lasagna cooking or something like this. So you've got the smell, olfactory sense, or you're seeing a really nice table that's got the food on it, nice filet mignon with some shrimp and stuff like this, okay? So here we've got sight, we've got smell, we've got thought, we've got a lot of higher order processes occurring in your head that starts the process rolling, okay? So that higher order, you know, your prefrontal lobe is going to be doing this. That is then going to send signals to your hypothalamus, which then sends a signal to your medulla oblongata. And the medulla oblongata is where the vagus nerve is at. Vagus, baby. So your vagus nerve is at. And is that sympathetic or parasympathetic? Now you should be able to answer this one, okay? So we're talking digestive system. We're talking vagus nerve. It's going to be parasympathetic, okay? So the medulla oblongata will send signals out via your parasympathetic. So here we have your higher order. Let me do Blue, I guess, is good. Let me just do this blue. Okay, so we've got the cerebral cortex sending it to hypothalamus, sends it to the medulla oblongata, okay, I guess, which is going to be in this area, okay, sends it out via a vagus nerve, okay, as we go down, and then the vagus nerve is going to stimulate or increase the activity of the stomach. It's going to start churning a little bit. It's prepping for the food coming in. It is going to start increasing the gastric secretions of your stomach. Everybody's known that their stomach growls. That's part of the cephalic phase, okay? So this is the thought process going in, and it can even lead up to the bolus going down the esophagus, because the next phase is when the bolus enters into the stomach, which then takes us, if I'm doing this right, okay, here's the gastric phase on here, okay, so this is gastric. Okay, and the gastric phase, again, begins when the bolus enters the stomach. It's regulated by your nervous system, and it's dealing with gastric reflexes. Now, we've talked about reflexes before. This is no difference, okay? This is where the bolus enters the stomach, and you have various sensory receptors in the stomach. You're going to have baroreceptors, which deals or detects distension of the stomach. You're going to have chemoreceptors, which is going to be looking at the pH of the stomach. So when the food enters the stomach, those receptors are stimulated, and they send a signal. So this is this one. They send a signal to the medulla oblongata. And what this is doing, now the baroreceptors is the stretch, the pH receptors, as you're adding the bolus to the stomach, the pH is going to rise, making it more alkaline, especially if there's protein in there. Protein is a buffer to the acidity of this. So if your pH rises, goes higher, that sends a signal to the medulla oblongata. And what it ends up doing is the reflex is basically the same thing as the cephalic or the other reflex, which is increased stomach motility, increased secretions, all of that, okay? Now, those are for gastric juices. Now, I also said in our previous video, there are 5 different cell types, 4 of which add to the gastric juices, 1 does not. You should know what that one is, okay? Because this is part of the hormone system. That 5th cell type is actually going to secrete a hormone. So that you should be in your mind right now thinking it's a G cell, and the hormone type is gastrin, okay? Gastrin enters your bloodstream, which is represented down here. So gastrin enters into your bloodstream, kind of loops back around to the stomach, okay? And what it does is it further stimulates the stomach contractions. It further stimulates the increase of hydrochloric acid secretion. Now, what cell type does hydrochloric acid secretion? If you don't know, go back to that previous video, okay? And does it secrete hydrochloric acid or does it secrete something else? Okay? So those are what we're looking at it. And this phase is also stimulating the pyloric sphincter to contract. And the reason it's contracting is we want to slow the emptying of the stomach contents because we need to churn it up a little bit more. Okay? The third phase is going to be, that's way over here, is the intestinal phase. That's going to be the intestinal phase. And what that's the wrong one that I want to do. The intestinal phase starts with chyme entering into the small intestine. Okay, so here we had the gastric emptying, the chyme was in the pylorus, squeezes past the pyloric sphincter, and now we have acidic chyme entering into the small intestine, specifically the duodenum. Okay? Now, this is going to be regulated by your nervous system as well as your endocrine system. The endocrine system, it's going to secrete two different hormones. Just briefly, it's going to be cholecystokinin and secretin. We'll come back to that here in just a second. And just like we had gastric reflex, we have an intestinal reflex. And the intestinal reflex basically is opposite of the other two reflexes that we just talked about, because we're slowing down the chyme from entering into the small intestine, because we don't want to overload how much chyme or acidic chyme entering the small intestine. We just want a little bit at a time. If we put in a little bit at a time, we have the ability to digest and fully absorb it. If we put too much in, the stuff is going through too quick and it doesn't come across and get a chance to absorb. Okay? Now, once the acidic chyme enters into the duodenum, now we have stimulation of nerve endings in here, and it's the vagus, where the acidic chyme sends signals to the medulla oblongata, and it stimulates it to decrease the vagal stimulation, the vagus nerve. Okay, the other ones increase stimulation. Here, it's slowing down that stimulation to decrease how fast or how much substance enters into the duodenum. Now let's go back, look at cholecystokinin on this one. Let me spell this out for you, because I always abbreviate because I can never spell it. So let me do this. Cholecystokinin. Let me spell this correctly. Where did I put it on here? Yeah, okay. CHOLECYSTOKININ. It's abbreviated CCK. Okay? I always abbreviate CCK because otherwise I spell it wrong. The other hormone is going to be secretin. So those are our two hormones that we're going to look at on this one. Now, cholecystokinin, we previously talked about it, but in regards to this aspect of what we're talking about, cholecystokinin, they're released by special cells within the duodenum, enteroendocrine cells of the duodenum, and they release their secretions, CCK, because of the presence of fatty material within the chyme. So there's released with, I should do it this way, fatty chyme. Okay, that's what causes it releases, and what it does is it decreases stomach motility. Now, we previously talked about it when we were looking at, I believe it was last semester, when we were talking about the gallbladder. Cholecystokinin also allows the gallbladder, or it causes the gallbladder to release bile, which then that bile then heads down towards the duodenum, which then deals with fatty digestion. Okay? But for our purposes here, this is now decreasing stomach motility. Now, secretin, let's kind of go over this area. Secretin, also from cells within the duodenum, and it's stimulated due to the presence of acid or acidic chyme in the small intestine. Okay? Now, the small intestine likes a more alkaline environment. The stomach is a high acid environment. Okay, so we want to. This is what's being secreted by cells of the duodenum, additional cells, secretin, and what this does is it decreases the amount of secretions that the stomach produces. So this decreases secretions from stomach. Okay, so that's what this one's doing. Now, both of these hormones deals with decreasing the secretions from the stomach. in this case. And both will inhibit release of gastrin. Okay, so this one and this one inhibit release of gastrin. What cell type releases gastrin? Okay, so that's the regulation of the 3 phases of stomach digestion. Next up, I really don't know. We're going to do something in the small intestine at this point, so stay tuned.